Hi everybody, I'm making this second video on the request of Albert. He just sent some emails on the group in which he shows us, or at least he shows me, how can we modify the Arduino Mega H-bridge program and therefore control the Arduino Mega to change its output frequency and to have more extra digital output pins enabled, so that when you, for example, when you click on a checkbox, the digital pins output is high, and when you unclick the checkbox, the digital pins output is low. So this would be equivalent to a light switch, if I may say so. So in this demonstration, first I will show you that the Arduino Mega digital pins 8, 7 and 8. This is pin number 7 where I have the oscilloscope probe stuck inside, and this pin is where the little wire is stuck in is digital pin number 8, to which I also have an oscilloscope probe hooked up. Okay, let me make some room. Where this LED is connected, you can see two alligator clips hooked up to one of the LED's terminals. That terminal where you can see those two alligator, my pronunciation sucks, where you can see those two alligator clips connected, that one is the cathode of the LED, and the other pin is the anode, and it is hooked to digital pin number, number 12. Okay, so if you want to measure the digital pins number D7 and D8, or 7 or 8 simply put, you must hook the oscilloscope probes into their correspondent slots, and the ground probes, the ground leads of the oscilloscope probes, you must hook them to the pin named ground. You can see it if you read down there on the board. Okay, enough talking. So first I'm going to upload the Arduino Mega program, the standard one, without any modifications, just to show you the 180 degrees out of phase outputs of the Arduino Mega as it is set up right now. Okay, so the program is uploading. Okie dokie. I can close this now, and now I turn up Electro Shaman. Okay, so Electro Shaman is on. Okay, now we go to serial port, we select our port. Okay, it's now connected. We start the pulse width modulation. We can decrease a bit the duty cycle, and now we can look on the oscilloscope. Okay, and as you can see, on channel 1 the pulse starts right here, and on channel 2 the pulse starts when during the period that channel 1's output is low. So if I modify the duty cycle, you can see there the pulses are complementary. Okay, so this being dealt with, I'm going to stop the pulse width modulation and close the Electro Shaman for now. Okay, now I have copied all these files into another similar file, and it is named just like the original file. I have made a folder in which I have wrote in my own language modifications of the H-bridge's frequency, and then in that folder I have created another folder named just like the original folder, in which we can find all these files, and that is Arduino Mega H-bridge. Okay, it is important that the folder in which all these files are placed to be named exactly as this file, as this Arduino file, Arduino Mega H-bridge. So if the name of the file is this, Arduino Mega H-bridge, you can see if I click on it to rename it, it's Arduino Mega H-bridge. Also the folder in which the file is placed must be named the same, Arduino Mega H-bridge. Okay, so this being said, I'm going to open the file, and now we're getting to the fun part. I'm going to maximize this window. Oh my god, I have so many wires in here. Okay, so now, as Albert has told me, I have saved his email. He said like this: you might want to slightly change the Arduino sketch called zp.h. Okay, so we go to zp.h. If my damn camera would focus, I would be very happy. Come on, zp.h. This is the one. Oh, wait. My Arduino wants to fall down off my table. I'm going to have to find a spot for it. Okay, now it's stable. So I'm going to open again Albert's message. You might want to slightly change the Arduino sketch file called zp.h and replace one variable. See below the code. Build and download. Then you will see the new slider of Electro Shaman will offer from 10 kHz to 200 kHz. Okay, this was a genius design of Dan Combine, so now no need to compile Java or Arduino and Arduino Mega. You literally design the Java graphical user interface content from Arduino via the USB or Universal Serial Bus. And this is the code: static struct ZP slider blah blah blah, and you have to see inside the file. So the file which we're modifying is what the, wait, it just disappeared. Must be a glitch in the program. Okay, let me go back again. So we select zp.h file, and you have to see inside the file where the heck is that paragraph of which he talks about. Static struct zp slider config 12. So if you see, it is right here. Static struct zp slider config 12. And now this is this has these values here: 10, 1000, 2 and 48 for the duty cycle, and these values are for the frequency. So if we open again Albert's message, we can see that the values are modified. Here is 100 and 200 main frequency, blah blah blah. From here on the writing is the same. So we go here, wait, how much was it? 100 and 200, and we input, instead of 10 we add 1 0, and here we delete 1000 and we put 200. Okay, what else? The rest of the rows here in Albert's message are the same. The values are the same for them. 248 main duty blah 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 for slider, so it's the same. Okay, and now we verify what modifications Albert has told me to do. And you have this button, verify. We wait until it verifies and see if we get any errors. No errors. And now we upload the program. Okay, now the program is uploaded. I'm opening now the Electro Shaman. Select our serial port. Wait until it connects to the Arduino. We start, stop, and the pulse width modulation. And now, if you see, we have 200 hertz, 200 or times 100 hertz, which here on the scope is equivalent to, let me measure it, because I have this option to measure the frequency. So he said 200 kilohertz. What the? Well, something's not right. Okay, wait. Well, this is giving me only 20 kilohertz, and I don't know why. Okay, let's close this Electro Shaman and let's see if we can modify and add one more zero here. Like so. Check the program for errors. It's okay. Upload it. It's okay. It has uploaded. Start back the Electro Shaman. Connect to the Arduino. Starting the pulse width modulation. And now crank up the frequency. Let's see. That's more like it. This is 200 kilohertz. So I had to add one more zero in the program, so it wasn't 200 here, it was 2000. Okay, and what I saw here is that you can, if you want to change, come on, focus. Damn camera. Yeah, if you want to change the frequency and have 1 Hertz granularity or resolution, you can just put your mouse here on top of the slider or cursor or whatever you want to call it, and just click once. So you see, it modifies the frequency 1 Hertz at a time. Or you can just keep the button of the mouse clicked and it increases 1 Hertz at a time. And if we go on the oscilloscope to show you, it increases nicely. You see? Nice and smoothly. Until it goes way up to 200 kilohertz. But I think that for our experiments 200 kilohertz is more than enough. Okay, let's see now. I'm going to close this Electro Shaman once again, and let's see now what happens if we modify here. Instead of 100 I input 1 and input here 2 more zeros. So we have here, it should be 200 kilohertz and starting from 1 Hertz. At least this is what I can understand from this code. As you know, I'm a beginner in all this. This is my first time messing with the Arduino and with all these, but some parts of the program, some parts of the code are just intuitive. So the program is okay, we're uploading it. And now start Electro Shaman once again, connect, and okay, now as I have modified it, it should start from, it should start from 1 Hertz. So let's measure the frequency. Crap, it starts from 1 kilohertz. So okay, let's stop it again. That means that this value here equates to 1 kilohertz. So if we want 1 Hertz, that should be 0.001. Let's see if it works. Yeah, it works. Uploading it and check it again. Up. Now this is an error on my part. I think that I should have let that value, because 1 means 1 Hertz, but I should have moved the cursor of Electro Shaman in order to refresh its settings. So selecting the serial port again, stop the pulse width modulation, and I move a bit the cursor so it knows that it has new values. So okay, let's measure the frequency. So this is okay. So this one value would be 100 Hertz. Then we should modify it to 0.01. Upload it. And check it again. This can be very time consuming. So if you're not doing so well with your patience, then I suggest you do something else. Wait. Okay. So let's measure the frequency once again. 200 Hertz. What the hell? So as I see it, the slider is set at 100 Hertz per division. So now here it says 4, and here I am at 400 Hertz. So I don't know, maybe Albert can help us modify this so we can have 1 Hertz resolution. But until then, I'll leave it as he told me in his mail, like this. Okay. Okay, so it says Albert said in his email, except I have added one more zero because the frequency was not correct as per his instruction, and gave me only 20 kilohertz. If I had let this value be 200, so I set it to be 2000. Okay, next, in his next message he says, try also to locally modify the main sketch and ZPH file. He made an error here, he said ZPH instead of ZPE. Okay, ZPH file. So the Java graphical user interface will have new checkbox button. Connect an LED to the D12 pin of Arduino Mega. So why so with, I think he wanted to say with. So with Electro Shaman you'll USB Arduino Mega, my man, control directly the LED. Yeah, I think everybody knows what he wanted to say. Just to give you a feel how you can custom fit your graphical user interface thanks to Electro Shaman modular concept, then unlimited possibilities from your imagination, creativity. Here he kind of mixed these up, but thankfully I sorted them out. This pin mode 12 output is in here in the main file here named Arduino Mega H Bridge. So if we scroll down the line, we can see here pin mode output la la. We select the cursor to be in this position and we add another row. Then I just go and copy this, insert it here, and voila, we have another command. The next commands, struct zp, checkbox, la la la, these are in the other file, but Albert did not mention that, except I caught on it. And we go to this file and you can see here the paragraph, struct zp, checkbox, and let's see, start stop pulse with modulation, start stop pulse with modulation. This line already exists, but this LED blinking line does not exist, so I'm going to just select this and copy it here. It is important that you don't miss anything, not even a sign like this, like the quote sign or paragraph sign. Even this comma must not be missed, because if you miss it you will have errors. And now, after I selected this region, I give it a paste, and now I have the command written by Albert, LED blinking. Okay, next. As you can see here, the next paragraph is empty, so is here. So I'll leave this section alone. The next commands are switch, CB, case, and I have searched in this file and they are not here, but they are in the main file, the Arduino Mega H Bridge file. Okay, and we scroll down the line and until we find the paragraph. So if you can see here, there is a function switch slider, and here we have switch CB. So we scroll down the line and we have found our function. Damn it. Switch CB. Okay. So we have here case 0 else, and we can compare it with what says here, case 0, start time of 4, and you check and see where are the modification, and the modifications begin here at case 1. So we look here at case 1 and we see that case 1, under case 1 it writes send log to graphical user interface checkbox not in use. And what Albert wrote here is this: if check digital write high low. So I select this from here, from where if begins and until here. I give it a copy and I select, afterwards I select from here and give it a paste. And now we have the command inserted in here. We look at the case 2, send log to graphical user interface, and compare it. Case 2, so it's okay. And now we verify our info, our commands. They're okay. It has given us no errors, and then we upload it and wait until the program uploads. It's okay, no errors. Now we start Electro Shaman. Select the serial port, wait until it connects. Okay, it's connected. And now, if you can see, besides the start stop pulse width modulation checkbox, which by the way works brilliant, so you can see the frequency modulation works, also the pulse width modulation. This is the pulse width, this is the frequency. Okay, so besides this, let me stop it. We have another checkbox in which says LED blinking, and if I click it, look what happens. As you remember, I have the LED connected. I'm going to try to capture both the LED and the checkbox. You see, it responds to the mouse. Now I'm clicking it and the LED lights up. Now I'm unclicking it, so it is unchecked. The LED is off. Now what I'd like to ask Albert is if he can instruct us further to make this checkbox of the LED blinking have its own slider, so we can control the output frequency and duty cycle for the LED as well. So it's okay that now we can enable more pins, more digital pins of the Arduino to have their outputs on or off, but it will be even nicer if we knew how to program the pins, so we can have program the Arduino so we can have control over frequency and pulse width of the newly enabled pins. So this being said, I want to thank Albert once again for instructing us in how to do it, and I hope you found this video useful. And once again, as you can see, the frequency is 180 degrees phase shifted, so it is perfect for a half bridge inverter in push-pull configuration, or a full bridge and if we could manage to enable the third pin to output another signal and phase shift all of the 3 signals, because we would have another one having 3 pins enabled, and it would be really nice to have the first pin output an initial signal, the second pin output a phase shifted signal. I don't know, it's 60 degrees phase shifted from the first one, and the third signal to be 60 degrees phase shifted from the second one. So we would have 3 different signals, and those would be perfect for driving a 3-phase H-bridge, so we could control 3-phase transformers and motors. So yes, the question remains, and my request remains open to Albert. If you can instruct us how to modify the output of a given pin and have it have its own frequency and pulse width modulation, we would appreciate it. So thank you very much everyone for your patience and attention. Thank you, Albert, for your dedication and patience and open sourcing all of these, and I'll catch you later in my next videos. Thank you.